All right. So
Anyone else logging on? Did you hear back from anyone?
no, it's already 4:20. So 4:20, blaze it. Just want to say that. So let's start with this element. And when I say give me everything, I meant give me the electronic configuration, give me what group it is on the periodic table, and give me the dot structure plus the charge.
I don't even know that I could do that.
So this is the element. I'm just going to type it.
Let me get my periodical table.
Oxygen. Okay. So I'm going to make the list of what the stuff that we need. Electronic configuration.
Yo, Alto, ¿ya comió? Yo hice sopa de frijoles con carne y arroz. Sí. ¿Quieres? ¿Te sirvo ahorita?
All right, so those are the 4 stuff that we need. I don't have a periodic table to show you here. Well, let me see, hold on. Can you guys see that? Hello,
Alija.
Yeah.
can you guys see that?
I can only see what you wrote. I can't see anything else.
Really?
Oh. I'll be right back, guys.
Mhm.
Bueno, ma, ¿quieres probar? Te doy a comer. ¿Eso no?
Hello?
I'm here. So what chapter are we doing now?
Well, I put up the question on the board and it's
Okay.
on 4 parts, A, B, C, and D. You have the oxygen, so you need to find out the electronic configuration of oxygen. What block is it on the periodic table, the dot structure, and the charge.
Oh, okay. I am back. Sorry, guys.
For the electronic configuration, is that like 2s2, 2p4 type situation? Or
Yes, yes.
gotcha.
Okay, can we go over how we derive at these
Can we
electronic
please do the
configurations?
Yeah, I do not understand the electronic configuration.
Okay. So the answer for this one would be, let me get my pencil now. Actually, just let me type it. It would be 1s, 2s, and 2p. But with little numbers on top. It'll be 1s2, sorry. 1s2, 2s2, and 2p4. So that's the electronic block, the electronic configuration. It's on block B. It's on the P block. And the dock structure is this.
So how does one derive at the, like, how do we, I need, my periodic table does not have, I'm looking for the one he gave us in class, but I can't find it. I'm printing a new one. Doesn't have the block.
All right, so remember I said that I found a chart for us?
Mm-hmm.
that we can use to remember the shells. I had a really good one right here. So you guys remember the quantum numbers, right?
That's at, the N, the L, M sub
quantum num-
L, and M sub S.
Yeah, the quantum numbers, which is the N, the L, the ML, the MS.
Mm-hmm.
Yes, those are the quantum numbers. Okay. Cool. And if I'm understanding this correctly, each quantum number is a level. Of the shell. So same thing with the S, SPDF. And how he explained it to us, he's calling this the off-bar order.
Mm-hmm.
So each N represents the shell of the electron. So the electron is here. This is the proton, the nucleus, whatever. And here's the outer shell. This first one will be called N1. The first shell will be called N1. The outer shell out of it will be N2. But before I can continue on, every N1 shell has a 1s. You guys understand that?
So every shell has a 1s.
Every element has an 1s.
Okay.
All the elements have an 1s. So the chart that I was saying that it probably might help you guys understand it would be this. Let me draw the chart here. You'll see why I'm writing them all down. Just give me a second. All right, so even though my graph doesn't look organized, but my numbers do, but okay. So at least you get the idea. This side here is the quantum number or the energy level of the shell, which I just remember I drew the little thing. Let's see if I can get better with this. So you see that? Hello?
Yep.
Hello?
Yes,
Yeah.
can you hear me?
Yeah, I can hear you guys. So yeah, so the order is this, and this is what I want you to remember. It's always going to go this in this direction. So it's 1s, then 2s, then 2s, 2p, 2p, and 3s, then 3p, 4s, 3d, 4p, 5s, and so on.
So each shell is gonna change to these with these orbitals? Is that what you mean?
Yes. So as more electrons get on the atom, gets on the yeah, as more electrons get on the atom, it changes the orbital. So they're not going to be on the same orbit. How can how I need to, I'm trying to put on my camera, but I can't seem to see. Hold on. Let me stop sharing for a second.
Mhm.
Okay, there we go. Go back to this. This disappeared. Okay. All right, so let me see if I can show you on my camera. Okay. I need a ball. Hello? I got a ball. Can you guys see it?
Yes.
All right, so when it comes to the first shell, the first orbit zone or the wave zone as is known as in waves, they don't travel in, they don't go around it, they travel out in waves. So the first shell, which is the closest one to the center of the atom, can only carry two electrons. So it'll be like one on this side and one on the other side going around in different waves. The next shell will be on top of it, this. So say like an see like an onion. There's the inner layer, there's the second layer, there's the outer layer, and that's how atoms are. Atoms are like in layers of onions. So the first layer will be the first orbit, also known as the energy level as well. To make it simpler, because pretty much the other quantum numbers, it's just talking about how the atom spin, how the atom orbits around the other section. So give me a second. Okay. But you guys know the order, right? Or no?
Got off bars. Order, is that what you're talking about?
Yeah, you guys know the order?
Can you go
A
over it?
little bit, but
Yeah, can you go over it?
All right, so as I have it here in this chart, that's the order. So for N1, erased all this. So for N1, which is the first shell, the one that's closest to the center of the atom, that one will always be 1s.
okay.
And 1s can only hold 2 electrons. So it will look like this. The minimum it can hold is 1. So it'll be 1s1 or 1s2 will be the maximum. That does not look like a
So the shell around the nucleus, right?
no, it's not a shell around the
not a
nucleus.
nucleus, but the shell around the innermost shell is always a 1s.
The first shell. The first shell. Yes.
Okay.
The first shell, the inner shell, yes. But the thing about atoms, the thing about the electrons is that they're not on top of each other like how you imagine an Earth's core. Not they're on top of each other like that, but not exactly in that. They don't look exactly like that though. They look like more of a how do I explain this? Like you ever see those little squishy toys that when there's like a bunch of balls inside, but when you squeeze and it's surrounded by this net, and when you squeeze the net, the balls pop out.
Mm-hmm.
That's how atoms are. That's how the electrons are.
Okay.
They don't touch each other, and in that exact moment, that's their own orbit in that part of the atom. And so
Okay.
that's how the most complex atom will look. So that's like so for that example, that would be like an atom with like 100 something electrons. So that's what they mean that each atom does not touch. So the order is to help distinguish how many atoms on there and in which section it's in. So that's N1. So N1 always has one S. Each atom always have each element always have this. They always have one S. After hydrogen and helium, after these two, after the 1s, everything else would be 1s2. So this one will be 1s1, and this one will be 1s2. And then from there on, everything will be 1s2 on top, following the next order. So these are the only two. These are the only two elements that pretty much just only has one S. By itself, I mean, one S by itself. So when they say what's the electronic configuration of hydrogen, it would be 1s1. The electronic configuration of helium, 1s2. So N1 always has one S. Next level, N2. And I have it here. N2 has these twos, 2s, and it has 2p. Remember the little chart
So that's
I
the
told
second
you?
shell.
That's the second shell, yes. The second level, the second shell. Remember the little chart I showed you guys?
Mm-hmm.
You guys have that or no more?
So not 2 has 2s and 2p.
Yes.
So how do you know how many shells each element has?
Now for this one, I don't know if you guys remember this from biology, but when it comes to the atom, the first, this is how they explained it to me. the atom. Let me draw that better. They explain to me like this. This is how they taught it to me with 3 rings. So they say anything in the first ring can only carry 2 electrons. The first ring can only carry 2 electrons. Anything from here and onwards, except for like, I think it's the 5th ring, I think it is, but we're not gonna reach that high, is all 8. The maximum they can carry is 8. So does that help?
So the maximum they can carry is 8, but how do all of them go up to 8? Or how are we supposed to know how many shells each has?
How are you supposed to know how many what?
Do all of them have up to 8 shells? Or do some have 3 and some have 8? Or do all elements have 8 shells?
That's okay, and it goes back to the periodic table.
Right, so that's what I'm asking you. How do we know how many shells per element?
How many shells per element? Okay, unless you have the periodic memorized, that's the only way, because as he was explaining to us, you're talking about like the elements down here in the bottom. And that's like pretty much going to the next level that he hasn't taught us. But
Okay.
I will answer your question. Just let me get to it.
Okay.
Just let me get to it. But I do want you to know that each level past the first one is always 8. So N2 will have 8 electrons. N3 will have 8 electrons. This is number 3 right here. N4 will have 8 electrons. And I'm pretty sure it's either N5 or N6 or N5, hold on. N5 would have double that, 16. So that's what I remember, is that I know that anything past the first one is 8, and I forgot there's one number that's like, I know it's more than 5 and it's 16. From there on, it's 16 electrons.
Okay.
So as long as you know that you need 8 electrons per shell, then you will know how to fill these up. That means you would need how many P's here and how many S here to equal 8. Remember, the S can only carry how many?
2.
2. 2 plus what equals 8?
6.
6. And which element is this?
Oxygen.
Hmm?
Oxygen.
Nope.
Oh.
It has a valence of 8.
Oh, okay.
That means this shell is full. Isn't that how it is?
No.
Because then I'm looking at the table and I'm pretty sure I'm like, wait, maybe it is oxygen because I see 2,6.
Yeah, I see 8.
Oh, okay, I get it. Okay, I'm seeing it now. Mhm. Actually, this is not even an element.
No.
Yeah, it's not an element. This is just basically just talking about this shell. I didn't include this shell here. So if I were to include the first shell, it'll be 1s, 1s2, 2s2, and then 2p6. That's how you will write for an element with including the first shell. But I was just talking about the second level, so that's why I confused myself. Sorry, guys.
Okay.
That's why I confused myself, because this is a full atom, which would be which one?
I am not sure.
This would be Ne. So remember when he said about when all the spots are full, that means there's 8 electrons in it. That's why it's called the octet rule. So everything on this side of the periodic table from here means all of their shells are full. Everything on this side of the periodic table means each shell has only 1 electron in it. The last shell only has 1 electron in it. So this one has the first shell. I don't know if you guys can see.
Yeah.
This one has the first shell, has 1 electron. He has the first shell
Lost you.
right here. He.
No, we lost video. Like we couldn't hear you.
Oh, can you guys hear me now?
Mm-hmm.
Okay. So He, remember the first S, first number 1 and right here will be 1s, 1 because it only has 1 electron. He, which is right here, also in the 1 part. So it will be 1s, but it has 2 electrons. So it'd be 1s2. And because the first shell only has 2 electrons, that's why it's full. It will be on this side. So do you see the elements? Any elements that are on this side where the numbers are? That means the last shell only has 1 electron in it. So this one would have how many electrons? If this one has 1, this one has 2, and this one has
The last show.
3.
lithium. Lithium, yes. Lithium would have 3 electrons. And how would they be arranged?
2 and 1.
Would it be the 3s, 3p, 3d?
Elmani was right, 2 and 1. 2 in the first shell and 1 in the second shell, which is the last shell of this atom, of this element, sorry.
Okay, I see. So
So this one would
if
have
the
a,
last shell has 3, the one prior to has 2.
this one will have 2.
2 and 2.
2 inside, yes, and 2 and 2 on the outside, yes.
Okay.
And then it jumps across. It jumps across to here.
Okay, so 5, 6, 7. So I have a different periodic table because I couldn't find mine. So the number on the top, like lithium says 3, the other one says 4, boron says 5, carbon says 6. So that is the number of electrons in the most outer shell, or
No,
altogether?
that's just the number of the, this is the number of the element. That's the number order. That's the third, that's the number what it's in. Hydrogen, yes, hydrogen, even though that's, it looks like that. To answer your question, technically, yes, but it's really just mean the order of the atoms. Like hydrogen really only has 1 atom, and it's really the first number of the first atom of the periodic.
Okay, so you mean the
first
numbers
element.
going down the left? That's what you're basing it on?
The numbers on the left is the shells.
Okay, that's the number of shells, or that's?
Yes. Every
Okay.
element in this one has 1 shell. Every element on this line has 2 shells. Every element on this one
So
has 3.
lithium has 2, sodium has 3, potassium has 4, and so forth.
No, potassium, which is what? Yeah. Potassium has 4 right here.
Has
4,
4,
5,
rubidium
6,
has
7.
5. Okay.
So that's how you read this part here. So I wrote it up here. These 2 rows are the S block. But I don't want to confuse, I don't want to change topic. I want to finish this before we can continue on with this, even though I might bring it up again. So I just want you to remember that. So let me make it simpler from you. So let me erase this. And 1, oops. And 1 will have how many electrons?
2.
2 electrons. And 2 will have how many electrons?
4.
Nope.
Eight.
If the first shell already has 2, the next shell, anything after that will always be what? What's the maximum I can have?
8.
8.
8. Yep, 8. And 3 would be
8.
also 8. N4,
8,
also 8. And from there on, like I said, I don't remember from here, so I'm also gonna put 8. So just remember that. As long as you remember that, then you'll be fine. The first one will always have 2. And then from there on is 8, 8, 8, 8. So I'm going to continue on to N3. N3. And that one has these two, 3S and 3P. N3 has that. N4 has something different. N4 has these, 4S, 3D, and 4P. And N5 has 5S, 4D,
5,
and 5P. Oh, gracias. So overall, the order is this. I'm going to write it out for you. It's a big line. So yeah, that's the order. I'm looking that he didn't go past element 29. So that means that it went up to only number 4.
So can I ask you a question?
Yeah,
Could you do your first question, right, where you put oxygen and then all of those things? Can you do a run through, like pick a different element and go through each and see how we derive at each one of those answers?
you want to do a problem now?
Yeah, I think by doing a problem and seeing how you derive at each one of the components, it would give me a better understanding of how to do it. I don't know if that works for everybody else.
All right, that's cool. No, that's fine. Up to everybody else. What do you guys want? Everyone else want to do it too?
Yeah.
Sure.
All right, so I have a next problem for you guys, for all of you. Hold on, let me fill it up. I had it here. So just give me the electronic configuration. Don't give me the extra stuff. Yeah,
Okay.
I just had it here. Give me a second. Okay, give me the electronic configuration of potassium. Actually, no, that's too much. Or what do you, yeah, you know what? Give me potassium.
So would potassium be 4S, 4P, 4D, 4F?
No. I'm gonna help you guys out by writing this. Okay. You guys want more hints?
Yes.
Wait,
19
wait, I'm just going really slow. I'm just trying to figure out like, how do you know how far to go? Like
Start by the
number.
first. Start for the first one. Every element has what?
Oh, so it's like hydrogen is the 1s1 and then helium's 1s2 and then
Yeah, exactly.
oh, I see.
Well, if you guys want a little clue or help, maybe this will help. This element has 19 electrons.
It's not 15.
Okay, how many? 19.
19.
All right, I think I got it.
It's not 15. Like I see 15 in the table.
19.
I got 19.
Okay.
It's on the periodic table and money right here. Potassium.
Okay.
19. So what will be the electronic configuration?
1s2, 2s2,
1s2, 2s2. Oops. Uh-huh.
P4.
2p4.
Yeah.
Okay.
3s2,
Okay.
3p4,
Okay.
4s2,
Uh-huh.
4p3.
4p3.
Yes.
And when you add all of these up, it equals to 19.
Yes. Is that really
Okay.
wrong?
No, you were doing great until you added the extra stuff, which is this.
Oh,
Yeah.
wait. Oh, it's 3D.
Not even. You don't need
No?
it. You
So
just need these.
why P has 4? I'm confused.
Wait, why the P has 4?
Yes.
It shouldn't have 4.
Oh, then
Remember the max, what the max the P can hold?
2.
6.
Oh yeah, 6. Yeah.
Because these break down into to the 3 P's, remember?
oh.
The P -1, the P0, the P1 +1, or the XYZ, whatever you want to call it, the 3 P's.
Yes.
So those break up into 3 P's, which carries 2 P's each, with 2 electrons each. So there you go.
Okay.
This would equal to 19.
Gotcha. Okay.
But you did good. No, you did great. You got it great. That's you just got the 2
Don't
numbers
erase.
wrong.
Don't erase yet. Let me see.
I'm still not 100% on this.
I feel like it's 20 now. The first one has 2, right? 1s, 2, right?
What, the first part here?
Yes. One
Yes.
is one. Yeah. 1s1
Every
or
element,
1s2.
every element has this. They always have this.
So
But it
it's
adds up.
1s1 or 1s2.
Huh?
1s1 or 1s2.
Both.
No, the first one I'm talking. It is 1s1 or 1s2.
How many electrons go in the first shell?
2.
Exactly.
Okay. The
There's
second
19,
one.
there's 19 electrons in here. We have to
Okay.
fill up each slots. These are the slots here. These are the
Okay.
seats.
Yeah, wait a second. The 2s2 has 2 electron too.
Mm-hmm.
And p has 6. That means
Mm-hmm.
10 electron. The 3s has 2. It's
Mm-hmm.
12.
Mm-hmm.
3p axis is 18. 4s has 2. That's 20.
Oh wait, so this
That's
was
it.
be 1.
Okay, that's how I would function. So it's
Didn't see that one.
4s1.
Thank you.
You're
Didn't see
welcome.
that one. So it's a 1.
Yeah, I was just okay.
But yeah, so yeah, Elmani is correct. This is how it's supposed to be. Why don't you get so, Johnny? So Johnny.
Sorry, I was on mute.
Oh,
I said it just confuses me how to derive at each. So 1s, 1 can only carry 2. 1s2, that's the maximum. Right?
the first shell.
Mm-hmm.
Yes.
Okay. Then 2s can only also carry 2.
Yes. All the S can only carry 2.
Okay. So and you don't jump from a 1s to a 2p. You always go 1s, 2s, and then p.
Yes.
Okay. And then the p, the maximum is 6.
Yes.
Okay. I'm just writing it all down. So 1s max.
Do you know the other way to write this?
Hmm?
Do you know the other way to write this?
Mm-mm.
Okay.
And then 3s goes back to max is 2.
Hmm?
And then 3p
Because it's an
max
S.
is 6. So any s is 2, any p is 6.
The max it can hold is 6. Yes.
Right.
The max it can hold for the S is 2.
And what's the max for d?
We haven't touched D. I don't think he's going to go there.
Okay.
Can you go over it in
But I
case?
think, no, wait, no, I think it's 6. Sorry, 6. D is also 6. I see it right here. Sorry.
So how do you know if you're applying? Well, you always have to go in order though. So it's always an S till you maximize, a P till you maximize, a D till you maximize an F.
Yes, but we're not going to go
Okay.
up that high. So he only went up to D, but he did not went up to P. He did not went up to 4P. He stopped. He went up to just to the D, and that's it. Hold on, hold on. 2, 3, 4, 8. 1, 2, 3. Okay, no, wait, I'm sorry, I got that wrong. D is 10. D is 10. So as you see from there on, you need more electrons as you go down the periodic table.
So P
Which
max is
means-
6, D max is 10.
D what?
D, the max
It-
is 10.
Yes, and the maximum
And
for
F?
P is 6. F, we don't know yet. We don't
Okay.
know. Yeah, we only went up to 29 on the periodic table. That's how far we went up to.
Can we do one more?
Yeah. All right, the next one is going to be nitrogen. Give me both the abbreviation and the long one, and the long way.
Or which one you said?
Nitrogen.
So how many electrons?
You don't have the periodic table?
No, I don't have it with me.
It
I'm not
has,
home.
it has 7 electrons.
7, okay.
So give me both electronic configuration and the abbreviation. I think I spelled that right. Oh. There you go. Okay. Yeah.
I'm not sure about the abbreviation. Is the configuration, is everyone done?
Well, is everyone finished?
I'm finished.
All right, just give me a second.
I'm just
I
taking
gotta
a
put my
stab
phone
at
on
it because
charge.
I'm not sure.
I'm
just
not
give me a
sure
second.
about the abbreviation either.
Is it 1S2, 2S2, and 2P3?
That's what I got.
Hello?
Yeah, did you hear me?
No, I just got back.
Okay, I said, I'm not sure about the abbreviation, but for the configuration, is it 1S2, 2S2, 2P3?
1S2, 2S2, 2P3. Yes, nice job.
Thank you. And then how do you, what's the abbreviations?
All right, so let me see if you can figure this one out. What element on the periodic table has their shell full before nitrogen?
Carbon.
Oh,
What?
the abbreviation is with the brackets of the previous element plus
That has their shell full.
Okay.
So which is the element that has their shell full before nitrogen?
BE. Right?
Nope.
Would it be helium?
Yes, helium, correct. So you were ready like this. You would take that, the one that has a full shell, He, and then just continue on, which was 2s2, 2p3. That's the abbreviated version.
Is he gonna ask for the abbreviated version?
He might
Gotcha.
ask you.
So how about BE? BE is full too. BE
No,
has
no, it's
4
not.
electrons.
No, it's not. Be is not full. How many electrons are in Be?
4.
4. How many shells does that one has?
2 shows.
2 shells. And which one is full?
I don't understand. So
The
uh,
first one is full. It has 2 shells. The first shell is full. The first shell can only has 2 electrons. So this one only
mhm.
has 4. So you take away 2, so you have 2 electrons left. So that goes in the outer shell.
Oh, okay. Got it. Thank you.
Helium is the one that has the inner shell, just like Be, but the thing is that this one doesn't have 2 shells. It only has 1, but it has only 2
Yeah.
electrons.
Okay, got it.
You got it?
Yes.
Can you
So-
repeat that? I'm sorry. And which one
What-
was she saying? E?
Beryllium, Be. The third element on the periodic table. It's on
Okay.
the second line, the second element.
Mhm.
Yes. I asked her how many electrons are in that element, and she said there's
4.
4. Right. So I said, if there's 4 electrons, how many shells does it have? 2. And how many electrons can the first shell have? 2. So that means there's only 2 electrons left. So how is this element full? It's not full because the second outer shell only has 2 electrons outside, which is what he calls the valence.
Yeah.
So the second one can hold how many?
8.
Okay.
Remember?
Mhm.
N1, which is the first shell, can only carry 2 electrons. N2 can only carry 8.
Got
N3,
it.
8.
Gotcha.
Okay.
So when you do the preceding full element in the bracket, you don't have to include then the 1s. You start from after that.
The only time they use this is when you're going down with the bigger numbers, the bigger elements.
Mhm.
Like for example, the one we were just doing with. Let's actually, before we continue on, let's give me the electronic configuration of argon.
Of argon?
Argon.
Okay.
Oh, that's
And
a
the-
long one.
18, right?
And that one has 18 electrons, yes.
Oh,
Okay.
You guys got it?
Yeah.
Yeah.
I think so.
All right, what's the long way?
S2,
1s2,
2s2,
2s2,
2p6,
2p6.
3s2,
You said 2s2?
3s.
Oh,
Two.
3s2.
Yes.
Okay.
And 3p6.
Okay.
That's what I got.
Yeah, that's what I got.
Yep. That's the electronic configuration, the long way of argon. What about the abbreviation?
Wouldn't that also be the abbreviation?
There's abbreviation in this one.
So I
So would it be neon?
yeah, would it be neon?
Right.
Oh, okay.
So how would you write it?
put brackets NE. And then 2S2, 2P6, then the rest of it?
3x2, 3p6.
Wait, it would be 2p6.
Oh, so you would start where NE would end.
Yes.
Got it.
NE has these three.
Yep.
Full.
Got it.
So this
10.
would be this. But now,
Makes sense.
now going on forward, how would you write FE?
Fe.
How would you
F-
write what?
FE.
Oh. Which way?
Both ways. This one has
You said
26
FE. What the
electrons.
heck is FE? Oh, got it. 26.
Oh,
There's
got
26 electrons in this one.
Hmm?
26 electrons.
Yes. So 1S, 2.
This is a tricky one. I hope you guys remember this.
I'm telling you right now, I don't remember.
I do.
Is
The letter D is a tricky one.
it's argon. And
You know how many D's you need, right?
yes.
Yeah.
It seems like you guys getting this much quicker than the math.
Yeah, this is easy. I like this.
There's a thing with the split that he's talking about, keeping it a balance, that I still haven't gotten the hang of it yet. All right, you guys got it?
So,
All right, what's the
Maybe.
answer?
Like maybe.
All right, who wants to give it a try?
it's 1s2,
Okay, 1s2,
2s2,
2s2,
2p6,
2p6,
3s2,
3s2,
3p6,
3p6,
4s2,
4s2,
and 3d6,
3p6. Did everyone get that?
Yeah.
Nope.
What do we get?
How did we do 3? Hold on.
Han obtenido entre fiestas y pesadas de manzana y canela una rica cucharada sobre su coso French toast.
Why did from 4S we went back to 3?
That's an energy level. That's because of the energy level of the D and the 4S are similar. I have to pull up another chart for that one. But my phone is charging.
Okay.
Are you gonna be at the school tomorrow?
Tomorrow. I can come like around 4:30ish.
All right, so I can show you the chart. So I
Okay.
can give you another chart for that. If not, no wait. If anything, if I can find the chart, I'll email it to you so you can see.
Okay.
But it's just like there was this other chart that has like lines about the P's and stuff like that, and it was telling you how the 3D and the 4S are very close, similar. So that's why the 3D goes there.
Gotcha.
But if you want to take a look at another perspective on the periodic table, I don't know if can you see my. Am I showing? Yes. On a periodic table, remember the blocks, the S blocks, the D blocks, the P, and the F block. So pretty much, the outer shell is ending in this block, which is the D block.
Okay.
So that's why it's going back to D.
Okay.
Because after the 3p is supposed to be the 3d, but it doesn't do that because it doesn't end in the d. It ends it ends the p's over here.
Okay.
So this block, S block, means these two lines are all the shells that end in S. All the shells that end in S. From this block, all the shells that end in D. The P block, all the shells that end in P. And all the shells that end in F.
Okay. Got it. Okay.
Because if you write it down, you see the last shell that we use. What's the last one for FE? Was D.
Ends in D.
D is in this block. When we did nitrogen,
Okay.
the last letter was P. P block.
And the same for argon.
Same for argon. The only difference for helium is because we just consider it that on this side, all of these just means closed shell, full shells.
Got it.
So how would you write this in abbreviation, in an abbreviated way?
It's argon.
Huh?
AR for
The argon?
S2. Yes.
Hold on. Let me see if I can erase this. Okay. Brackets AR.
For S2,
For S2,
3d6.
3d6. Yep, that's the abbreviation version of it. So you see, this is why we use the abbreviation version. So instead of writing this whole damn thing, we just write this and boom.
I hope he doesn't make us do that.
It's better to know it than you know.
No, I know, but
So
more
that's
room
chapter
for
7
error.
for you. This is just chapter 7 with a mixture of chapter 8. I'm not getting on into detail of how they discovered all of these shells and everything. That was he already bored me up with that story.
So what
Wait.
kind of questions do you think he would ask with this is all quantum numbers?
Quantum numbers, the periodic table, and the bonds.
At 6. At 6
So,
o'clock. Yeah,
huh?
gracias.
So that's chapter 7 with a hint of 8. Let me bring in number 9 and see if you guys refresh your memory on that. So going back to oxygen, what is the charge for the oxygen? You already know the valence. You already know how would you write the electronic configuration? And you know how many elements, how many electrons this has, right? So what will be the structure for oxygen? Hello?
The structure you said,
Yes.
that's like the Lewis dot thing, right?
Yep.
Um,
I'm going back to oxygen. So
okay, yeah. So there's 2 lines and 2 dots.
where we replace the lines and dots.
You would place the lines, one on the top left and one on the bottom right, and then the dots like on the other corners.
Like this?
No, like I don't know, does it matter?
Yes.
Well, I guess diagonally, like a normal, I don't know how to explain it.
Like that?
No, oh my God, I don't know how to explain it.
Diagonal going this way
Yeah,
and the 2 dots.
yeah.
So 2, 4, 2, 4, 5, 6.
Mm-hmm.
I don't see
I
the
would
screen.
do the electronic configuration. What's the electronic configuration? You'll see it.
Okay.
Of oxygen.
Yeah.
So, is it 1s2, 2s2, 2p6? No, 2p4.
Mm-hmm.
So 2, 4,
So how many electrons are in the outer shell?
4.
4. No, 6.
This is just showing you the outer shell. Just image here is just how the element looks from the outer shell. The outer shell will only
Oh,
have
only the outer.
only the outer shell. We'll only have
Okay,
this is how the shell will look. Valence, the valence of 6.
got it.
2 are in one orbit. Another 2 are in one orbit. One is in the own orbit, and the other one is in its own orbit. But yeah, that's another technical term that I'm not going to touch. So how do you find the charge? This is
Oh,
the
it's
only
that
formula that we need.
formula.
This is the
It's
only formula we need. Yeah.
the number of valence electrons minus the covalent bonds minus the non-bonding electrons.
Yep. That's the only formula we need.
Can you explain though where you get each of those numbers from?
Yep. Right now, I'm dealing with one element, so then I'll show you how you get the other numbers. But I'm going to show you right now how to get this, how to get the charge for this guy. Okay. I think this is a bad example to use, but what's the valence numbers of electrons for this guy?
6.
Right. And the covalent bonds.
Sorry, I couldn't hear.
The valence numbers of oxygen of this element right here. What is it? It's 6. Remember? That's how many electrons are on the outside of the shell, which is the valence. That's what it means. Valence numbers of
Okay.
electrons. How many numbers are on the outside of the shell of this element, which is 6 electrons. Minus the number of covalent bonds is not connected to anything, so it'll be 0. This number of non-bonds, technically this is for molecules, but this question also is number of electrons of the atom, of the element. And how many electrons are in here? There are 8. 8 in
Wait,
total.
why is that 8?
Because there's 6 on the outside and there's 2 in the middle.
Gotcha.
So then we do the minus 6 minus 8, the charge is -2.
So then this is pretty much the non-bonds, it's just everything together.
The what?
The non-bonds is the
No,
entire.
no, no, no. I'm only
electrons?
using this one because non-bonds is meant for compound elements.
Okay,
It's when there's like an element and another element, like 2 oxygens or oxygen and hydrogen, like that. I went with this one because we're dealing with a straight element, just it's single thing. So I went with the electrons in the element.
okay.
It'll be the same way with if you do nitrogen. Nitrogen has a valence of 7. Covalent bonds, how many covalent bonds are in there? 0. And how many electrons does nitrogen have? I mean, no, sorry. It has a valence of 5.
How do you get the valence number
N-
from?
Nitrogen? Wait, how do we get the valence? What does the valence mean?
I thought the valence was the number of the shells.
No. Valence means the number of the last, valence means the last shell.
Okay,
Valence means the last shell. So when it's saying the number of valence electrons, numbers on the last shell, how many electrons?
so the maximum. So on oxygen, on which one you said?
On
Nitrogen?
oxygen is, on nitrogen it's 5.
Right,
On nitrogen the valence is
2
5.
in the first, 5 in the second. So the last would be 5.
Yes.
Okay,
0 bonds because we're talking about with one single element. And how many electrons in that element? There are 7.
7.
So we do 5 minus 7, you get a charge of what?
-2.
Nitrogen is tricky, but it has a lot of charges, but yes, you get -2. Nitrogen has a lot of charges. It has a 1, it has a 2, it has a -1, -2, has a 5, 4, 3, and a 2. It has a lot of charges, but yeah. Now, I'm gonna be using this formula actually now. So I'm gonna give you a molecule to use. All right, so we're gonna do H2O. What will be the structure and the charge? Y'all need more time?
Yeah.
Yeah, one.
Oh, shoot. I was looking for you. All right, everyone ready or need more time?
I'm ready, I think.
You can review it. I don't know if I got it right, but you can review it.
Yeah.
All right, Hope, what would be the structure?
Oh. I don't know if I did the structure right. I just did, well, so how I set it up was I did like the O in the middle and then I did like the H's on each side of it. And then like a line connecting it.
All right. Do you know,
Um,
do you know how many valence you're working with?
Oh yeah, we can like go through that. So hydrogen has one, right? Or did I already
There's-
start off wrong?
One valence.
Yeah,
How many hydrogens are there?
two. So then it would be two.
And
And
how many
oxygen
valence?
is 6. So it'd be 8. And then you divide 8 by 2 and you get 4.
So we already used up 2.
So you have 2 more. So then I just, because you only had 2 more, I also put the lines in between the oxygen and the hydrogens.
You put a line and you put another line here and another line
Yeah,
here.
yeah, like I just did like double bonds. But I didn't think that was right. I literally had no idea.
Technically, it's supposed to be like this. A dot on the top and a dot on the bottom. But knowing him, he might just want us to draw a line. So yeah, that's what the last 2 would be.
Okay, and how would I like know to do that? Because like obviously it's
Well, remember the element, right? You're dealing with hydrogen. How many electrons can hydrogen have?
how many electrons can hydrogen have? 1. Oh,
One.
so you can't put any more there.
No, because this line equals 2.
Oh. Okay.
And this one also equals 2. So you also need 1. So this is already set with 1. This was already set with 1. And this one you already have, here you have 2. But we split them up, so now they only have the 1. So you got 1, 2, 3, 4. The rest of them will have to be in oxygen because this one can only take 1.
So wouldn't hydrogen have 2 dots, not one?
1, yeah, wouldn't it have a dot and not a line?
There's 2 electrons left. Wasn't it like that? Oh wait, are these the bonds? Because if I wrote that wrong, then it would be like this. Line, line, then a line, line over there. Right, that's how it is. Those are the 4 right there, the 4 bonds. These meant bonds, I forgot. This meant bonds. There were 4 bonds in there. We used up 2 to make the molecule, and then we had 2 bonds left, right here and right here. So then it would be like this: H, line, O, H, line, 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 H. So now we have this full of 8, and this one full of 1, and this one full of 1. 1, 2, 3, 4, 5, 6, 7, 8. This is full, and this is full.
Okay, I'm gonna need more practice on that.
So there are 2 bars around the oxygen.
Yeah.
Okay.
Excuse me. This is from chapter 9, right?
Chapter 9, yeah.
Okay, I have to go over that again. All right, I have to hop off.
Yep.
But I'll keep reading, and then I guess through the group chat we'll set up the other study group.
Yeah. Can you also come to the school tomorrow? Because I need your help to study for AP. I'm doing muscles.
Yeah, I can be there like 4:30.
All right, thanks.
No problem. All right, I'm hopping off, guys. Good night. Thank you, David.
You're
I'm gonna
welcome.
hop off as well, honestly.
Do you at least, did it help?
It helped me because I was confused on the two on all that, so I feel comfortable with that. Now I need to focus on this.
Yeah, I agree. Like now this is like my priority.
Chapter 9.
Yeah, I just have one question. What is like, where do you get the number for the non-bonds?
So going for this. Now we can use this with this example.
Yeah.
We have to find it for each one. So let's start with the H. How many valence does the H have?
1.
1. Covalent bonds. You know what that means?
Covalent bond. Yeah. Wouldn't there be 1 covalent bond?
Yes, because there's only 1 here. So that would be also 1. And the non-bonds charge, anything that's non-connected to the O, we have
So
nothing.
there'd be 0.
It'll be 0, yes. So then this charge will be 1 minus 1.
Negative
Plus-
1.
No, it's 1 minus 1, 0
Oh,
minus
1
0.
minus 1 is 0.
So the 0 charge will be 0. It will be 0 here. So this will be 0. Then this charge will have to be what?
0, 0, and
0.
It has to be
1.
0 as well. It's for the cell to be neutral.
Okay.
So then now we're going to do the same thing. How many valence does O have? 6. Remember? 6 valence.
Yeah.
How many bonds are covalent? How many bonds are you sharing with? Just 2. I'm going to erase that. And how many non-bonds does he have? These are the 2 non-bonds, this one and this one. But electrons, non-bonds electrons. So there's 4. 1, 2, 3, 4. There's 4 electrons. So now we do the math. 6 minus 2 minus 4.
6 minus 2 minus 0.
Yep. So that's how the whole thing is neutral.
Gotcha. Okay. I got it now.
But when it says non-bonds of electrons. So these are the ones that are not connected, but electrons, the little dots. So if this one had like a line and 1 dot, then it would have been 3. Because each line is equals to 2 dots. So each line is 2 electron, and 1 dot is 1 electron. And in order for an element to have a bond, the valence shell, the outermost shell, has to equal a total of 8. So you see how
Okay.
this valence has a total of 6.
Uh-huh.
This one has a total of 1 and a plus 1. You get a total of 8.
Right.
Now, O is satisfied, H is satisfied, 8 and H is satisfied.
Mm-hmm.
Here's what you need to know about the periodic table. Again, going back to chapter 8. Anything from here to here, they want to donate a hydrogen. They want to donate an electron. They want to donate electrons. Anything from here over here, they want to receive an electron.
Got it.
So you see how H is on this side, it's going to donate electrons. The oxygen is on this side, it's going to receive the electron. So that's how H and O connects to oxygen.
Got it. All right. I think I understand this.
Yeah, basically the chemical structure of water,
Okay.
the math
cool.
part.
All right. Thank you for your help. I really appreciate it.
You're welcome. Any more questions? Just ask me and I can help you out. Don't be shy to ask me.
All right. Thank you once again.
You're welcome.
All right. Have a good night, David.
Have a good one.